All right, day 3. How's everyone feeling? How are your heads? Yeah? Did you have fun last night at the party? Yeah. Good. I hope you didn't drink too much because we got a crazy day today. Lots and lots of content. And as I mentioned at the first day, we're going to interleave platform-specific stuff with some ISO stuff, but it's all about C++. So today we're going to start the day off with focusing on Windows. And I'm sure, as you could imagine, Windows is composed mainly of C++, and the Windows team mainly of C++ developers. So you're going to learn about sort of the latest platform that they've created. And we're going to start off with Alesh Holicek, who is the vice president of the platform.
Thanks, Charles. Well, good morning, everybody. I see lots of kind of glazed over eyes. Party was good. I'm happy for you guys. Thank you, Charles, for the introduction. I'm Alesh Holicek. I lead the Windows platform team, which we call the developer experience team. And my talk is going to be probably a little bit different than some of the talks which you have heard so far. Hopefully you will not fall asleep after the great party. And it's kind of not entirely our time. It's kind of early in the morning. My talk is going to be about sort of how we use C++, how we apply C++, how we think about C++ in context of Windows, and how we are evolving sort of our commitment to C++ going forward. So the place I want to start is, look, it's a journey. There is no one stable point. It's a journey which we are all on with respect to how we think about operating systems, how we think about OS system APIs, how we think about how we program these things, because the world is changing on us, and we have to be dynamic. We all have to, if you are a Linux guy, Android guy, Windows guy, whatever guy, we all the time have to think about how we want to respond to the ever-changing world around us. If we stay stagnant, we will become irrelevant. And so, just like the rest of the industry, the Windows team and Microsoft, we are part of that journey. We are on that journey. My talk is not about C++ compiler design or language design. We have experts in our company which we defer on those type of and they're all sitting here in the first row, which we defer on those type of subjects. And so I'm approaching this talk and everything which I will be saying from the perspective of a practitioner, user of the language, to get my job done. And not just my job, but obviously the job of the team, which I'm part of. And so I touched kind of on the whole concept of the journey. And so for us, a big inflection point on the journey was at the beginning of Windows 8. And so I will do a quick little survey. Who played or plays or runs or uses Windows 8 on their machine? Please kind of like raise your hand so I kind of know what audience I'm talking to. That's pretty impressive, so that's good. So another question, just so you guys know, kind of like majority people, which is awesome. And thank you for that. Second question, who attended any kind of build conferences or any conferences where we talked about how we think or thought about building Windows and Windows 8 and so on? Please raise your hand again. OK, much fewer, which is good, because that makes my content more relevant. And so I'm excited about that. So here we kind of go. So let me kind of take you on the journey which we went through and sort of some of the design points and decisions which we had to go through as we were building Windows 8. And just for your information, we are like inches away. Officially, we have RTM'd, which means released to manufacturing Windows 8.1, which is an update to Windows 8. And our OEM partners are now consuming the bits and building factories or whatever, turning on factories in Asia to build all of these computers for Christmas. So we have officially RTM, but we are still fixing last set of bugs and improving the experience. And so when I will be talking about Windows 8, I'm really talking about Windows 8 and Windows 8.1. We kind of think about this as a one big continuum. So when we started with design of Windows 8, we kind of realized that there was this big shift into a mobility, this big shift into how people use computers. prior to iPad, we all were sitting in front of a big TVs and big computer monitors with big towers shoved under our desk, and we were doing a lot of computing in this way. As iPad and mobile phones and all of these type of devices emerged on the market, and they got consumer adoption and acceptance, a lot of the computing which people do on a day-to-day basis is actually moving into you just walk on the street and you hold your device and you are doing most of that computing in a mobile way. And so now there's a very interesting physics and dynamics thing which is happening, which is how much experience we can deliver per watt. Okay, like before this, we were talking about parameters of computers in the sense of how many GBs do you have? Like it was like the RAM or storage or something, but like the GB thing was kind of like you were like a dude if you had a lot of GBs, or dudette in some cases, like lots of GBs equals to like a street cred, right? Now it's really about how long does your device last, right? The battery is becoming very defining part of the device, and so we started to ask a question, not how many GBs do I have, but how much experience can I deliver per watt, right? And it's a very, very different question. And so as we started to think about what it means for the OS design and for the programming model design and all of that type of stuff, we had to kind of ask the questions like, what does this API, what kind of impact does this API have on the battery life of the system, of the device? And so we had to start to really hardcore manage this really precious resource, which is the battery. The battery defines everything about the device, right? It defines the size, it defines the weight, it defines everything which really matters to the consumer. So we also had to start to think about, well, how do we offload as much of the stuff which the thing is doing to some piece of silicon in the device? How do we push stuff into a hardware? And we have done a lot of work, and not only that we have to offload it, but we also have to give you and us great enough access to the offloaded work to the hardware, so we can actually program these subsystems and we can reason about these subsystems. So we have rendering, composition, encode, decode, media encode, decode, things like capture, Wi-Fi, crypto, and many other things, which we are just pushing down to the silicon and letting the silicon do its thing in a super battery efficient or energy efficient way. The other thing which is changing on us with the devices, as I said, like you walk with the device on the street, is the expectations of you as the consumer, not this time as you as the programmer, or the developer, is that the device is continuously connected and in two different ways. So you expect that device is all the time up to date, right? Like if I look at my email, it turns out to be up to date. Like if there is some geofencing thing, I'm walking around Starbucks. This is kind of the mythical unicorn scenario. I'm walking around Starbucks and it like, ding, ding, there's an alert, Starbucks coffee for free. So I walked in and get juiced up and moving on. Like those type of things are super important for us. The device also needs to be reachable, which means somebody can call me on that device. Like the devices which we are building are increasingly more, not used only for computation, but also for communication. And so reachability of the device, similar to phone, voice over IP and things like that, super important. So the next thing which we kind of thought about with the mobility stuff is customer confidence. And we started with the word security. We used the word security, and then we said security is the wrong word. We need to use the word confidence. And confidence is all about, am I willing to use software on these devices, right? In Windows 7, when people installed Windows 7 on their machines, the number one and number two most installed software was some kind of antivirus system or a browser. Those two things, web browsers, those two things were the things which people install on their machine. And so we had to think about, if we, as a software developers, if we are going to go and change the world, and if we are going to deliver awesome pieces of software, we need to make sure that people are willing to install the software and have a confidence about the fact that the software is not going to harm their machine or their data or whatnot. And so for us, things like easy on, easy off for a software package, super important kind of tenet. the system had to be protected. So like I don't suffer from, I install a piece of software and the thing kind of stops working. That's always bad, right? And we all have stories about that. Hey, I installed this game and I cannot boot my machine or whatever it is. We wanted to make sure that the data access to your data as a customer consumer, the data is reasonably transparent, so you know what's going on with your data. So that when you install a tic-tac-toes, there is not some kind of a sound of slurping, uploading all of your data on some evil server. And obviously, we want to deliver a PII protection, personal identifiable information protection, your location and things like that, which is on par, not necessarily the same, but on par with the web. And so you can see that once we start to go through all of this, you kind of start to think, well, what do I have to do? What do I have to do in the operating system and in the programming model of the operating system to deliver on some of these super important tenets? Because I think that they are reasonably agreeable that that is important for us to go and do. While all of these are important, we also have this very open or reasonably open system, which is called Windows. And we did not want to hoard that either. And so we did I don't know if that's actually a good word or not, so, but I will use it anyway. So we did not want to break that either. And so Windows actually delivers not only this mobility based system, but it also lets you do all of the awesome stuff which you could have done with Windows before. And so the other thing which kind of drove us was new interaction model. Think about touch, think about pen. Those things are super interesting when you think about latencies, for example. How long does it take for a message on a UI thread to get from the digitizer when the thing, your finger or the pen, touches the glass? How long does it take before the app knows that something like that happened? And it turns out that if you want to develop a great user experience, that time cannot be more than 30 milliseconds. Preferably, it should be shorter. The typical UI thread of an application, at least in Windows, is ticking somewhere on the order of 150, 200 milliseconds a tick on the UI thread, because there's a lots of stuff happening on the application UI, on the main thread of the app. And so you can see that those two things are kind of incompatible. And so what do we do to solve these problems? And so that was kind of the beginning of the journey. Those are the questions which we asked when we started design Windows 8 and sort of the new generation of Windows. And so everything from this point on is going to assume that you understand that these are good things for us to do. I will kind of touch briefly about how we approach these things and how we use C++ in solving these problems. So the key Windows investments were, like, we did a user model, and the world is split. And I'm obviously being polite saying that. So there's a split opinion. So there's part of the world which thinks, yeah, you guys did a really good job. And then there's part of the world which thinks that we didn't do a good job at all. And so we are obviously learning and improving. But then there's three other things. There's the deployment model for apps. I talked about the easy on, easy off confidence. What does that mean? There's a runtime model for the apps, which means, hey, how much computation can I do per watt, and how much battery do I kill by running this app? And then there's a programming model to support all of these, and we call that the Windows runtime. So let's talk a little more about Windows runtime and C++ usage in the Windows runtime. So before I get to the C++ usage in the Windows runtime, let's just talk about C++ usage in Windows. So overwhelmingly, majority of our code is written in C++. Pretty much, if you want to be a developer on a Windows team, you will write all of the code you write in C++. There are some people who write assembly code, no doubt about it. There are some people who write C code, no doubt about it. But overwhelmingly, vast majority of code is written in C++. Our C++ code is, we keep it mostly simple. We try to keep it mostly simple. We use the language, we try not to abuse the language. And so we use concepts like encapsulation and inheritance and many of others. We have people who frequently or infrequently go and bring some new stuff into our code. But for the most part, we try to keep the code base very consistent and the usage of the language mostly simple. We are COM users. I want to be clear about this. We are not ashamed of it. We love COM, and we use a lot of COM throughout Windows. We built in C++, everything from the low-level system code all the way up to all of our UI. And unlike some previous attempts of a platform, we truly use C++ everywhere. It's not like a weekend project. This is the thing which we do. This is the thing which we live and breathe. We write our stuff in C++. So some of you, many of you, most of you, I don't know, have heard of WinRT. Raise your hand if you heard of WinRT. Perfect. So WinRT is not the same thing as Windows RT, just to be super clear. Okay, Windows RT is a SKU of Windows, which is a marketing construct. WinRT is the successor to Win32. Okay, so it is the programming model for Windows Runtime, and it's tricky because even we kind of keep stumbling over ourselves as we talk about it. So WinRT is the programming model for Windows Runtime. And so the way how we think about WinRT is it is the ABI, it's not API, it's the ABI where B stands for binary. So it's the application binary interface surface to interact, for applications to interact with the system. It is entirely written in C++. Some parts of it are COM. We are using the COM in a very light way. We use concepts like free threading, cross-context, and cross-process marshalling, and things like that. But we try to highly modernize it, and I talked about what I mean by that. It's great for C++ devs. The whole WinRT is great for C++ devs. Why? Because we are C++ devs. So we wrote that thing for us. We kind of are committed to that. We are not only committed, but we made our bed. So now we have to go and sleep in it, right? So we wrote WinRT in a way that we can use it, we can consume it, and we can build everything which we need to build in C++. And we hope that it's also going to be good for you. Now, I'm not confused, and we are not confused. WinRT is not complete. It's not finished. There is more work to be done, and some of the work needs to be informed by the things which you guys need from us. And so part of this whole thing is, I said at the beginning, it's a journey. And part of that journey is journeys have forks and crossroads and things like that. And so we need your information so we can kind of refine our point of view about what WinRT should be and shouldn't be and how to take it forward. And so part of get-togethers like this is having that conversation. We also wanted to have a platform which is applicable to all languages. So here in the room, we all love C++. It just turns out that there is other group or groups of people which program in other languages. I know it's hard to believe, but they exist. I have seen them. And they program in all kinds of different languages, and they are really good at it. And we want them to program to Windows too. There's nothing wrong with that, right? And some of them program in C#, and some of them program in VB, and some of them program in JavaScript, and some of them program in Python, and the list goes on. And so we want them to be able to program in these languages also. And so we wanted to have a platform which is usable in all of these languages without having to recode the platform every time you decide to choose language, because that's very expensive and it doesn't work out. And I talked about all of these different offloads, and so getting the offload and the control over the hardware to be really, really good, again, that is super important for us. And C++ turns out to be C and C++ turn out to be really, really good languages to get that work done. And so that's kind of how we frame or how we think about WinRT internally. So now WinRT provides a lot of different services, if you will, for you. It goes from very fundamental things which you would expect, like threading and timers and memory management and stuff like that, to device access, media access, all kinds of networking, communication, data serialization and deserialization, and obviously it goes all the way up to user interface, where we give you access to DirectX and accessibility stuff and a whole bunch of controls and angle brackets called XAML, which those of you who program on Windows probably know from WPF and Silverlight. For those of you who don't, they are just XML way to express user interface constructs. And so WinRT is pretty complete. Now, it's not done. There is a lot of missing, and lots need to be added or changed or improved. But we think that we have a reasonably good starting point, which we can evolve and move forward. So the basic concept of WinRT is WinRT objects, and objects are exposed as classes, as I said. Like these things are this is all written in C++, and so these classes, we call them runtime classes. We have very, very carefully organized all of these classes into some namespaces to make the API surface for Windows to be super usable. The following speaker, Elliot, who is going to follow me, he's a part of API review board, which we review every API, and we are very deliberate about how the APIs come together, how they compose, and how the organization of the API surface looks like to make sure that people can use it with ease. As I said, these APIs are crafted for composability. We have done a lot of work to make sure that the versioning of these objects and classes is very well defined and lets us move through versions of Windows relatively seamlessly without breaking applications. We have two ways to think about versioning: either additive versioning, where we add new interfaces, new classes, or we deprecate the old ones when we figure out that those were no good or what have you. And all of the WinRT objects are described by static metadata. And so at this point, some of you C++ people who are like, C++ does not use metadata, we know, or at least didn't up until now, right? So we know that C++ doesn't use metadata, but we needed the metadata. We need something to describe these objects statically on the disk. And so what is the metadata? It is a complete and concise description of each object, which is independent of the code. Like I can reason about all of the objects which are available or implemented by the operating system without having to go and look at and parse any code. Like I can do that just looking at the metadata. The metadata is generated by compilers. So the way how it works is that you type C++ code and then you hit compile or type make or whatever you do, and as a side effect of the build process comes out this metadata file, which is a binary file. We tried to make it as efficient as we possibly could. We actually went and talked to our friends in the .NET world, and they had this file format to describe objects. It was called the CLI metadata, and we're like, seems good. You guys worked on it for a very long time, and so you optimized that format quite a lot. And so we took that format and used it for describing objects in the Windows runtime. It's rich enough for us to support all kinds of different languages, right? So we are, like I already talked about it, people, other languages, good. It describes these languages for C++, but also these objects can be directly consumed by JavaScript interpreters and other CLR and other language runtimes. And one thing which it gives us is it gives us awesome developer experience. You wouldn't believe how great, maybe you would if you use Visual Studio, and if you don't, you should go and try. But you wouldn't believe how awesome the developer experience becomes, because now we have full IntelliSense and we can fully reason in a static way about all of the stuff which Windows exposes. And so that's kind of Windows metadata. There's nothing wrong with header files, which kind of describe the same thing, but we ask the compiler to kind of help us to reason about these objects in a runtime without having to parse source code in the runtime. So here's kind of a, because you guys are a super technical audience, and like it would be a really mistake not have something which at least looks technical. So far it was all bullet points, right? So here's kind of a diagram of how we think about Windows runtime or WinRT runtime class. So it is a COM object. It has the standard COM stuff, IUnknown. It also has IInspectable, which lets us do most of the magic. It exposes whatever set of interfaces it exposes. You see that as the iStorage file, and iStorage item, and iStorage item information. That whole thing is called file information runtime class. There is a registry. We have registry in Windows. That registry registers these COM objects for creation. That's where we go and look for these objects when we are trying to create one. And then we have, on disk, we have this Windows metadata thing which describes everything about the class, so we can very quickly reason about what this thing is, what this thing can do. So that's kind of how this is the mental model which you should have when you are thinking about what is this object thing, what does that look like. As you can see from the picture, it's just COM. It's a whole bunch of e-tables. It's all just C++. But we are helping ourselves, and we are asking the compiler and all kinds of different tools to help us to reason about these things in runtime and in just a sec. In runtime and during the tooling experience.
Okay, because I've just been using COM objects, and they're very difficult in Windows 7 because you look at the object and it says, oh, I have I unknown. There's actually like 50 functions in the file.
Yeah.
Drivers and stuff. And I said, oh, we'll have to trace into it to figure out what it can do.
Yes.
Not what it does do.
Yes.
What it can do. This will fix that.
Yes. So the question was, or the statement was, there was no question. It was a reinforcement of the work which we have done, which is like, hey, in Windows 7, when I deal with COM objects, I know there's I unknown, but that's about all I know. And then I have to trace into it. When I open the header file, I look at it. It's just this long list of things. I don't know what they are doing. And I have to effectively step through all of this stuff to figure out what it can do or cannot do. And this should fix that. And the answer is yes, it should. Like, that is the whole idea behind what we have done here. So this is WinRT runtime class in a nutshell. This is how you should think about it. So how do we build these things? So we wrote this Windows runtime library, right? Because we had to build these things too. Like, we have to type the code. Like, that it doesn't automatically emerge. So WRL, the Windows runtime library, is effectively a template library which is designed to help us build these ABIs, okay? These objects. Vast majority, not all of it, but a vast majority of WinRT is written using WRL. WRL is focused on very basic and simple set of things. It's class definition, activation, fundamental types, async patterns, delegates, things like that. So that's what we get out of WRL. WRL is not ATL. I hope that everybody knows what ATL is. So it is not the same thing as ATL. Only the basic set of idioms of COM, only the things which we needed to construct these runtime classes were included in a WRL. So the nice thing about WRL is it's included in our public SDK. Anybody can go and use WRL. Like, you can start today. It's there since Windows 8. All of the fundamental parts of the WinRT object creation, all of that stuff is fully open. You can use it too. As a matter of fact, if you are Ninja and if you are a COM Ninja on the top of everything, we encourage you to kind of go and look at how we have done things so you understand what goes into it. So there are header files like implements.h, which define the runtime class and things like weak reference and IUnknown and IInspectable, and so that's what happens there. Then we have event.h, which defines delegates and our eventing infrastructure and whatnot. We have big focus on async APIs. The reason we did async is, I told you about, hey, touch and pen, it really needs to be responsive. And so the big question is, how do you get long-running operations off of the UI thread? Well, our answer to that is obviously async, right? You call the API and effectively let the system push it off into a background. And Iho is going to talk about that a little later. And so the async pattern, the definition of the async pattern, including the state machine of what it does, is included in async.h. And you can go and examine it and play with it and understand what we are doing, and it's all open. WRL is exception-free. When I told you we are kind of simple users of C++, in Windows, we don't use exceptions, for better or worse. Windows started before exceptions were available, and we don't use exceptions. And so effectively, all of our programming is happening against return codes. And so everything which we do effectively has to handle a return code, which kind of maps into the very obtuse programming which already was mentioned here, which is like, here's what it looks like when you are using WRL and you are trying to create one of these objects. Like, you you have a computer, and in this case geolocator, and you have result, and you call activate instance, which is the equivalent of com create instance, and you give it this identifier, which is a string in this case, and then reference is going to be assigned into your geolocator variable, and then you must check if you succeeded or did not succeed it. And then if you succeeded, then you probably go and do some query interface on it and make some calls into that thing, and life goes on. And so this is what programming in COM typically looks like. And for those of you who've wrote a lot of code in COM, you'll find out it's pretty obtuse and pretty verbose and whatnot. And so we wanted to simplify it. We wanted to simplify it quite a bit because this was a lot of work. And so we went to Herb and said, Herb, what should we do? Like, this is like not cool. Like, there's a lot of work to be done here. And our fingers hurt from all of the typing. And so Herb said, we should do C++ CX. And C++ CX is effectively taking all of the stuff which WRL does for you and pushing it into the front end of the compiler. Let the compiler do the work, right? And so C++ CX is effectively taking all of the work which we as the developers have to do and modernizing the C++ language in a way that we can deal with these constructs which have a different lifetime, for example, different lifetime than typical C++ objects. We had to deal with that. We wanted to not call QI after every other line of code, so we wanted to have things like auto QI. We wanted to use exceptions because that's the modern way to do this. We wanted to organize our code into namespaces, so again, modern way to do this. And so we really wanted to move from the simple way of using C++ and enable ourselves, because we have to type that code too, and obviously you guys to write code which is kind of a modern C++ code. We have using CX, we have simplified our threading model quite a bit. And so to the extent that you never want to know what is a COM apartment, this is a way to avoid that. It enables us to use PPL for all kinds of async stuff. And async is super important for us. It further enables us to use async across a whole bunch of different languages like C# and JS. It's great syntax. It's really lightweight syntax to express all of this complexity. C++ CX is not designed to replace your standards-based C++. It is an addition, it is an augmentation of that. And so I need to speed up a little bit. So here's what the code, which I showed 3 slides back, looks like in CX. So you say auto geolocator ref new, and you give it the name of the object, which is nicely namespace. It will create it or throw an exception, and then you say, geolocator get position async, and it will do whatever it does. And if there's a problem, it will throw an exception for you. Like, this is a modern way to write pretty complicated code. You don't need to know about QIs. You don't need to think about complex QIs and whatnot. You just write the code which you think you should be writing. So we've used we use WRL and C++ CX for a long time now, as you can imagine. And so I kind of wanted to share quickly with you what we've learned from using them. We use it both in the apps and we use it also in the operating system. So the first one is do pay attention to performance. That one is kind of like duh. Like, we all use C++ because we are after perf, right? It just turns out that some of these new constructs add additional overhead. And you need to be aware of where that happens. So because C++ CX is a boundary, it is the ABI between the OS and your application, you really have to make sure that you understand what's happening on that boundary and how often you are crossing that boundary. Like, avoid chattiness. We definitely, like, if you want to write a particle system as an example, and every particle is a WinRT object, it's not going to work out very well. You want to probably have the particles which get created and destroyed all the time. You want to have those particles to be just lightweight C++ objects. So definitely avoid using these heavier constructs in performance-sensitive way. Avoid any algorithms that need to move data across this boundary quite often. Type conversions are can be super costly. If you use STL and if you use WinRT collections, which is a construct for us to marshal things between different languages, and if you set up a relationship which have conversations both ways, this can be very, very costly. We had a great talk at Build 2013, which Sridhar did, which was all about the performance of CX and how to manage this boundary. And so to the extent that you guys are going to be writing this kind of code, I strongly encourage you to go and watch that talk and flip through the slides, because you will avoid a lot of the pitfalls. So you can choose your dialect, okay? And so you can use WRL. It goes down to the metal. For the purists, which don't want to have anything to do with CX, and we fully respect you and support you, and please go crazy, go use WRL. It is a C++ in its purest form. It's templates. There is nothing odd about it. It is definitely a good choice for places where you are not having exceptions, or where you did not introduce exceptions yet. But it will test your comm knowledge for sure. Like, you will have to understand what's going on. CX, which our own developers asked us for, the developers working on our team, please simplify my life. It's great for building user interfaces. It's great for developers which just want to consume all of these constructs without understanding deeply about what's going on underneath it. It is a very modern language, language extension, and it is very easy to use. Now, CX can very quickly bleed into your app code, and so be careful as you are using CX to not let that bleed happen, or be intentional at least about that bleed. Pay attention to making sure that your core code, the code of your app, stays portable. So those are kind of our key learnings from consuming it ourselves. So now, another good important thing is, look, the Visual Studio tooling, we have done a lot of work to improve the tooling for C++ in Visual Studio. As a part of that work, we obviously did a lot of work to make sure that CX is well tooled in Visual Studio. And so the tooling there is quite good. You get a great IntelliSense, you get a great debugging tools. And obviously, I spoke about Journey, and so we are not done yet. This is a point in time, and we are continuing. We'll continue, improve, and evolve. And more you give us a feedback back, better it all will become. We have also written all of our samples in CX for you guys to quickly understand what's going on and how to use it. So in summary, because I'm slightly over time, the whole WinRT has been written by C++ developers and for C++ developers. We have written it for the other guys also, but just don't tell them that it's written in C++. Our recommendation and our experience right now says, look, go and write most of your application logic, as much as of your application logic, in a portable way, in an ISO C++. It's totally a great thing to do. Interact with WinRT very carefully. Understand what's going on the boundaries. Make sure that you're intentional about type conversions and that type of stuff. WinRT, when you write code in WinRT, please give us a feedback about how things are going, what's working, what's not working. It is really, really, really important to us. We believe that the next killer app, which is going to emerge on Windows, is going to be written in C++. Why? Because it's going to be optimized for performance. It's going to be taking full advantage of all of the stuff which the hardware can do. And the last thing is, look, the journey continues. I already touched on it. We are not done. We are committed to this journey. We started on that journey some 5 years ago at this point, and we will keep going. And we want to have a conversation with you guys as you write your own code, as you port your code, and giving us feedback is really, really important. And so please, let's keep the conversation going. And so with this, I want to conclude this part of the talk and hand it over to Elliot, which is going to take you way lower in the stack and talk to you about threading and async and concepts which are way more, I think, interesting. All right, so thank you. Thank you, everybody.
Thank you, Alesh.
There's the